Using the TI-83-84 Plus calculator for rank correlation. This video uses the example titled, "Do better smartphones cost more?" The TI-83-84 Plus calculator is not designed to calculate the rank correlation coefficient from original sample values, but we can use the calculator for that purpose. The basic idea is to replace the original sample data with ranks, then proceed as if we were calculating the linear correlation coefficient. If the original sample data are not already ranked, replace each of the original sample values by its corresponding rank. In this example, the data from the table titled Ranks and Costs of Smartphones has been ranked in the table titled Ranks of All Data. The quality rank data has been entered into list QLTY for quality, and the cost rank data has been entered into the list cost. Once the data has been entered into lists, press the Stat key, then press the right arrow key twice to select the top menu item of Tests. Use the arrow keys to select the menu item LinReg T-Test, and then press Enter. You can also press the alpha key, then COS key for F to access this function. On the LinReg T-Test screen, the blinking cursor indicates the current input item and highlighted selection. Press Enter after each entry to move to the next input. For XList, enter the list containing the ranks of the first variable. In this example, we enter the list quality. For YList, enter the list containing the ranks for the second variable. In this example, we enter the list cost. For frequency, enter the default value of 1. For beta and row, choose does not equal 0. Press the down arrow key twice and Calculate will now be highlighted as indicated by the blinking cursor. Press Enter again to view the results. The results include the p-value, correlation coefficient R, and test statistic T. Press the down arrow key twice and scroll down to identify the value of R. Because the calculation of R is done using ranks, the value shown as R is actually the rank correlation coefficient. In this example, the rank correlation coefficient is found to be negative 0.79643 rounded. Caution: ignore the displayed p-value because it is calculated with the t-distribution instead of the correct distribution for Spearman's rank. Using the critical values of Spearman's rank correlation coefficient appendix table, we can find the critical values of plus or minus 0.648 based on the significance level of 0.05 and n equal 10. Because the correlation coefficient of negative 7.9643 is outside of the range between the critical values of negative 0.648 and positive 0.648, we reject the null hypothesis. There is sufficient evidence to support a claim of a correlation between quality and cost. It appears that you do get better quality by paying more, but this conclusion incorrectly implies causation. Remember, correlation does not imply causation.